Okay, hey guys, so this is going to be a video about the, Higgs boson, the, one they hope to discover at the LHC. It would give particles mass. And so this is a little animation I made of the Higgs mechanism. It's not great, it's not even average, it's completely awful, but I figured it will be sufficient to show how it works. So let me run it here, and I won't say anything for this, but I'll commentate it over later to show you how it works. Okay, so that is it. Yeah, it's pretty bad, and it was, yeah, pretty simple to make. I mean, I just used paint to make it. But, anyway, I just used paint. So, here, let me commentate it over to show you how it works. So, this is the top quark experiencing the Higgs boson. As you know, the top quark is extremely massive. That's a top quark. That is a virtual Higgs boson. And so you can see as the top quark moves in, it attracts all the Higgs boson. So here, let me move it to that part. And as you can see, the top quark is attracting the Higgs bosons as it moves along. As you can see now, all the Higgs are starting to get dragged along by the top quark. The drag that the Higgs creates, that's what we measure as mass. And so something like the photon would just, which has no mass, at least a real photon does. A real photon has no mass. It would just go straight through, and none of the Higgs bosons would be dragged along by it. So, and since there's no drag from the Higgs, since we don't measure any of that drag, there would be no mass. So that's how you get a massless particle like the photon. So as you can see right here, the top quark starts out, and the Higgs are evenly spread. Then next, you can see that there's the top quark. It's going on a trajectory up the screen. As it moves up, the Higgs start to be attracted to it and dragged along by it. As you can see, those two are being dragged along by it. And now those are all being dragged along by it. So, since the top quark is very massive, it has lots of drag. It drags along lots of Higgs bosons in this virtual field that coats our entire universe, made of virtual Higgs. And the top quark has lots of drag in that field, as in, through that field as the top quark moves along, as you saw in this animation here. This last part right here, as the top quark moves along, it drags lots of Higgs bosons behind it. And that drag is what we measure as mass. And like I said, the photon would go straight through the field without dragging any Higgs bosons behind it, and that's what we would measure as no mass. And say something like the muon neutrino, which has a very small mass, or something like the electron, or even the electron neutrino, which has like less than 3 electron volt mass, which is really tiny. Those would drag on very few Higgs bosons. So I hope you enjoyed this, and I hope it was helpful to you. Sorry for the bad animation quality. I just had to do it in paint. So, yeah, thanks for watching. Bye.